Alrighty folks, this is the last video for the day. This is on page 290 in your packet. This is the first AP problem. This one we're going to go through together just so you kind of get the idea of what it's asking you to do. Yeah, so this is not going to be one of those that is due at the end of the unit. So here we go. This is from 2008. There are 4 parts here. Consider the closed curve on the xy plane. Boom, there it is. Cannot be explicitly defined for y because we have y to the 4th and 4y. Doesn't work. So, part A, they tell you the derivative is this, but they want you to show that. So, I'm not going to explain that in great detail. If you need to pause the video to see it, there we go. But that is your derivative. Those are your steps. So, part A is right there. Part 2, write an equation for the line tangent to the curve at the point -2, 1. So they've given us that point. We can use this derivative with that point. We first need to plug it in. So this is part B right here. We plug in -2, 1 into our derivative, find that the tangent slope is 1/4. So when we use our point slope form with the point that they gave us, that is our final tangent line. There we go. Again, if you need to see that a little bit more, pause the video, take a look, but I'm going to keep going because those two were pretty easy questions there. Part C, find the coordinates. So coordinates, find it, meaning we can actually do it. They wouldn't have asked us to do it if they wrote it like that. They wouldn't have asked us to do it if it wasn't possible. So find the coordinates of the 2 points. They've already told us it's going to be 2 answers on the curve where the line tangent to the curve is vertical. So, a couple things. Vertical tangent line, that happens when the denominator up here equals 0. That happens when y equals -1. So knowing that, I need to find x because they told me I should be able to find x and y to get my ordered pairs. So if y is -1, I just plugged it in into the original curve function, not a function, it's just a curve. Whew, sorry, got to get used to that. Plugged in -1, and I'm able to solve for x. It's a very nice quadratic. It factors very nicely. So it was very easy to find that x is -4 and x is 2. And we knew that y was -1, so here are my 2 points. Those 2 points have vertical tangent lines. There we go. That's part C. Again, nothing too much going on there. Again, if you need to pause the video, go ahead right now. Let's move on to D because D was a little bit more tricky for me, I know, so I want to make sure that you guys have a good explanation of it. Part D says, is it possible for this curve to have a horizontal tangent at points where it intersects the x-axis? Explain your reasoning. So notice, is it possible? That's telling us that it might not be. It's possible that the answer is nope, can't do it, done. So we need to figure this out. So it's not asking us to find or asking us to describe. It's saying, is this possible? Tell me why or why not. So here we go. I went about it this way. I know that on my x-axis, all of my y values are 0. That has to be true. And then, separately from that, so that's item number 1. Item number 2, I know that a horizontal tangent happens when my numerator of the derivative equals 0. And I can't be undefined, which I already know happens when y is -1. So when this guy, the numerator, equals 0, that happens when x equals -1 and y doesn't equal -1 because this would mean that the derivative is undefined, so I can't have them happening simultaneously because the undefined part will kind of win out. But luckily, I already know, notice I said huzzah, if y is 0, I already know it has to be 0, it can't be -1, so that part is good. So this part's kind of redundant to say because I already knew that y had to be 0. Done. Okay, so now the question is, where does this happen? If y is equaling 0, where does that happen on my curve? So what I did is I plugged in y equals 0 into my function, which was very nice. It made the y's go away. So I have a x squared plus 2x equals 5. Subtracted that over. Again, that's a very nice quadratic. Solved it out with the quadratic formula. Got this, and I know that this is a funky square root, so I know that this whole shebang isn't negative 1. It can't be, because negative 1 is a very nice whole number. Square root of 24 is not a very nice whole number, so there's no way that this is going to equal negative 1. Reason why that's important right here is because I already said here, the horizontal tangents will happen when x is negative 1. But we just found that the x-axis points happen here. So this guy is representing x-axis points. This guy is representing horizontal tangent points, and they are not the same thing. Therefore, is it possible? No. Because, I wrote because twice, because horizontal tangents only happen when x equals negative 1. But since the x-axis has y values of 0, we know that this curve only touches the x-axis at this location, which is not negative 1. So horizontal tangents might exist, but they are not on the x-axis. That's what we can say about that one. So something to that effect, some explanation that says that is what I need to see on a question like this. So showing me the work and showing me the reasoning behind it. Don't just like do random stuff. Explain to me what's going on. So, as you need to, pause, rewind, rewatch this video as you need to. Again, this is one that we just did together in class. This is not going to be one that's due at the end of the unit. But this is a good example of how to do the ones that you will have to do by the end of the unit. So now, for homework, let's take a look at these. We already did page 291 last night for homework. So for tonight for homework, I would like you to do page 292. So that's homework from Wednesday to Thursday. And also page 293. Homework on Wednesday as well. Notice there's another AP problem. This is the one that's going to be due 2 days before the Unit 4 test, which won't be for a few weeks. But make sure you have it done, and it fits, like I said in Tuesday's class, it fits with this topic. So I would do it now since this topic is fresh in your head. There we go. And we'll go over those homework assignments tomorrow, which is Thursday. There we go, and I will see you then.